Ok. Așa, asta rămâne și
Prin setările lui.
I welcome you all to our first afternoon session on GIS and remote sensing. My name is Juliana Armaș, and I'm a professor from the Faculty of Geography, University of Bucharest, and with my colleague, Assistant Professor Ștefan Constantinescu, we are the chairs of this afternoon session. We have 7 presentations on different topics of GIS and remote sensing, most of them dealing with different GIS application fields aspects. Because as our schedule is very tight, I kindly request the speakers to give us a very short presentation of the main results of their research, and to keep in 10-12 minutes time those presentations. So we have at the end of them also a few minutes time for questions and discussions on each subject. Without any intention to put also pressure on the speakers when they got close to the last 2 minutes of their presentations, I will pull up this notice paper so they know that they have only 2 minutes left and they can summarize and draw some conclusions. So let's begin with the first presentation on North Atlantic Oscillation and East Atlantic indices variations and their impact on water turbidity in the Danube Delta coastal area. And I invite Sorin Constantin to give us a talk about this subject.
Okay, thank you very much for the introduction. Good afternoon to you all. I will try in the next minutes to briefly present you a short study regarding the correlation between turbidity in the coastal area of the Danube Delta with some teleconnection patterns that occur in this area. First of all, I would like to stress out the main objective of this brief study, which is to investigate if and which are the correlations between water turbidity, as I said, and large-scale atmospheric forcing in the Danube Delta coastal area at monthly time scales. For this specific objective, we choose 2 teleconnection patterns. We focus mainly on the first one, which is the North Atlantic Oscillation, but we took also in consideration the second one, East Atlantic and West Russia pattern. We already know from previous studies from the literature that for the Romanian coastal area there is a strong inverse correlation between now and the occurrence of storm, meaning the storminess characteristics of the area, which means that when we have negative values for the now index, there is a very good chance that we have high occurrence of storms in this area. And also we know that the shoreline dynamics are dictated on decadal scales by these phases of now. We are trying in this study to use probably for the first time some remote sensing data sets in order to see these relationships. And for this we are using turbidity as a parameter, which is one of the many parameters that can nowadays be measured and monitored using satellite oceanography. First of all, some few words about turbidity. Why did we choose turbidity? Well, first of all, we choose it because there is a very high correlation between turbidity and reflectance. Turbidity being an optical property, which through backscattering coefficients is very closely related to reflectance in specific regions of the electromagnetic spectrum. There is, for this specific area, there is also a very good correlation between turbidity and TSM, which is the total suspended matter concentration, meaning the total sediment loads in the water column, with few very basic differences, which regard CDOM, which is color dissolved organic matter, and other pigments that influence only turbidity and not TSM measurements. But these influences are very, very low in our case. For this specific study, we had first of all to establish a regional relationship between turbidity using in situ measurements and remote sensing reflectance using, of course, satellite datasets. So the first step was to gather, to make some field campaigns and to gather enough in situ measurements in order to derive such regional relationship. Concerning remote sensing data, we used MODIS datasets coming from both from Terra and from Aqua platforms, and we took into consideration the first spectral bands, which have the best spatial resolution, meaning 250 meters. The first one is centered at 645 nanometers, meaning in the red region of the electromagnetic spectrum, and the other one is centered at 859 nanometers, meaning in the near infrared domain. And based on such pairs of turbidity and reflectance, we established a regional relationship which can be seen on this slide. Regarding the area of interest, we defined two such surfaces. One is a big one which covers the entire coastal deltaic area, which is noted as AOE1, area of interest 1, and we also delimited a second one, which is situated in the southwestern part of the larger area, and is delimited by minus 20 meter isobar. We choose this specific area close to the shoreline because analyzing multiple products of turbidity, we discovered that there is a quite distinct distribution of high turbidity values in this area, which is directly connected to the seasonal distribution of resuspension processes. In other words, during winter months, winter periods, we have found out that in this specific area, small area, these resuspension processes are overwhelming, and the turbidity extension and turbidity values are more influenced by such processes than the deluge discharge. Because we consider that here is the area that most probably will be influenced by now and ever, because what I forgot to mention is that these teleconnection patterns influence indirectly the turbidity by determining the energy provided by winds and waves in this area, winds and waves that are directly responsible for resuspension processes. And we try to see if this hypothesis is correct, and for this we try to make a correlation between turbidity measurement in this area and wind speed, and we found a quite good correlation, 0.67. The next step was to analyze this relationship using all 144 months available, because the period that we took into consideration was between 2003 and 2014. And what we discovered is that there is quite no correlation if we take into consideration the entire year, the entire spanning of measurement. But we already know that now and April also might influence this area, especially during winter when we have a lot of storms and the energy of the wind and waves is greater. So we decided to take into consideration only these time periods from the cold season. And what we discovered is that what regards now, we have moderate correlation. The correlation coefficients are minus 0.5 and minus 0.57 for the two areas of interest. Of course, what can be noticed is that when now indices are have quite low values, meaning it's more than minus or around minus 2, we have a very important increase in turbidity values in the coastal area, which means that, of course, these teleconnection patterns influence what happens here, but we have to take into consideration that other factors might be implicated, such as marine currents or algal blooms, or even, and most importantly, Danube discharge. For the East Atlantic and West Russia teleconnection pattern, such correlation was not found. The conclusion was that there is no such relationship between the two. So only now seems to influence this area. And jumping to conclusion, first of all, we can say that Earth observation data can contribute significantly to coastal processes, analysis, and monitoring. Longer periods of time should be taken, of course, into consideration because we only analyze 12 years of data sets, but probably if we take longer periods of time, we should be able to understand more in-depth the phenomena. And also changes in atmospheric conditions at larger scales can have an indirect impact on the distribution and dynamic of sediments in the coastal areas, but other factors, as already mentioned, such as river discharge, marine currents, or algal blooms, might have more significance in specific areas. And finally, the coefficient correlation was found to be quite good, but only when we are discussing about winter periods and not the whole year. So briefly, this is what I had to present. So thank you very much for your attention. And if there are any questions.
Thank you, Solid. Constantin, we have time for 2 or 3 questions or remarks. Please. In English.
So, the idea is that even if you increase the time period, the time span, you will have fluctuations. And an overall, let's say, statistical estimation, like correlation, might not be quite correct. In my opinion, you should narrow your analysis on certain period, and you should introduce those factors. Because, for example, I have seen Freddy Vespermano presented in applied geomorphology section that they have storminess. They have a storminess index, so you can see when you have storms, and you also have the solid discharge for Danube Delta. So you could use them to eliminate those influences and to see the teleconnection if you manage to get something much.
Okay, I understand. First of all, we already did this. We narrowed the period of study to winter times, when we know already that these teleconnection patterns have the greatest influence. Second of all, 12 bits of data, it's not enough, because as you already probably seen in what Mr. Vespermano presented, this variation of now can have very great dynamics. So for the time period that we analyzed, now was mainly in a positive phase. So this means that we didn't have very much events of stores. So probably we didn't, uh, we couldn't see what would be the ideal situation in order to monitor such correlation. But in order to have larger time span, this would mean other problematic areas. You will have to take different sensors into consideration. You have to treat intercalibration issues and other stuff.
Thank you. If there are any more questions?
I have examples for one satellite pixel. So we have 150 meters, kilometers, one satellite pixel, but how many samples you do? You said that would be also in measurement.
Yeah, the in situ measurements were done mainly in order to establish a relationship between turbidity and reflectance. And based on this relationship, we then computed more than 9,000 products, satellite products. But in terms of in situ measurements that were taken, we had around 90 sample points. Out of 90 sample points distributed near St. George Mall, but not in the same pixel. I mean, the span of the pixels, and we managed to have a quite large span of measurements from 1.8 FTU up to more than 200 FTU, which is very high turbidity.
And these were only surface samples, or?
Yes, only surface measurements, because also the satellite sees only what is happening on the surface of the water column.
If there are no more questions, I invite Mihaela Gheorghe from the University of Bucharest to give us a presentation about PINSAR techniques and applied over Bucharest using the DCX satellite data, and to show us differences in these techniques and in the results obtained.
Thank you for the presentation. Hello everyone. Today I'm going to present two remote sensing techniques, other remote sensing techniques that we apply to detect substance in Bucharest. So my presentation consists in answering the common three research questions: why, what, and how, presenting a few initial results, and talking about conclusion in the end. So first, the context, or the answer to the question why. This study is part of an ongoing project that is studying vulnerability of Bucharest urban area to hazards. When we are talking about hazards, usually we are thinking about fast developing processes like earthquakes, flooding, or fire. But in this case, we are talking about subsidence, because subsidence can also be considered a type of hazard, even though it has a larger developing scale in time. The changes that can occur are smaller. In the end, the influence can be quite important. So it can affect infrastructure, it can influence the seismic response of buildings, but also create damages to infrastructure due to fractures. So in our capital, which is a city prone to disaster, prone to earthquake, we consider that subsidence can be considered a hazard that needs to be investigated. So we decided to use satellite remote sensing, radar satellite remote sensing techniques because they are widely used, recently became widely used in this application. What is the basic principle of differential interferometric SAR? Well, when the ground is moving, it causes a phase shift between acquisitions. So we have the radar satellites that are passing over the same area the few days, and the movement of the ground surface can cause a phase shift in the signal. So we are using the phase shift of the signal to depict the rate of displacement suffered by the surface. We are using SAR images, and by multiplying the first SAR image with the complex conjugate of the other, we obtain the interferogram that contains information about deformation and topography of the study area. But because we are looking at subsidence, we want only information about the deformation that affects the area. So we subtract the influence of topography from our interferogram, and we only obtain the deformations that affect the area. So we have the fringes, the color patterns, and a full cycle corresponds to a displacement of the surface with half a wavelength. It depends on the wavelength of the sensor that we are using. It can be the half of 3 centimeters in case of high resolution satellites, or half of 6 centimeters of medium resolution satellite, 4 centimeters. So, the techniques that we are using, the INSAR techniques that we are using, are actually multi-temporal. So instead of using only 2 SAR images to obtain an interferogram, we are using a stack of images. In this case, we are looking at pixels in images that have a reliable phase measurement over time, so that remain coherent over time, and we obtain points on the surface for which we can investigate the movement in time. By looking at the way we find these reliable pixels, we have 2 multi-temporal techniques. The main multi-temporal techniques that we find in the literature are permanent scatterer technique and the small baseline flashback technique. The permanent scatterer uses pixels that are represented by radar targets, so man-made objects like buildings, infrastructure, or rocks that don't present vegetation and they have stable signaling time. The small baseline subset technique uses highly coherent areas. So instead of using radar targets, objects, it uses area. Another difference between the 2 techniques is the way that they form the interferograms. If the persistent scatterer technique uses only one main SAR image and interferograms are formed as using this master image as reference for all images, the small baseline technique uses more master images and more snake images, because it looks at the temporal and distance baseline between the acquisition, because it tries to obtain the best coherence possible. So in our study we used 27 teraSAR images because between 2011 and 2014, so almost the span of 3 years, the wavelength of the sensor is 3 centimeters, so I'm talking about the high resolution sensor, and we use software Starscape from SAR. Our results show very good agreement between measurements. So in the left we have the PS analysis, the permanent scatter analysis, and in the right we have the small baseline analysis. And also, although we have smaller values for velocity in the small baseline analysis, we can see that the velocity patterns are very alike. We also investigated the behavior of some points in some areas. We have here areas that are affected by substance. And we can see also that the time series, behaviors, and type of the points can show the same tendency, which is good. But if we are looking at the PS time series in an area that is not showing substance, it's another area, we can see that the PS time series in comparison to the small baseline time series show a lot more noise. This is normal if we look in literature and also if we look at the algorithm that we use, because the PS time series look at objects while the small baseline looks at the surface. So we expect that objects in an area behave differently while the surface, a wider area behaves the same. So the conclusion is that in a vulnerability study, it's good to use both techniques because PS is better for infrastructure and point analysis, while small baseline is good for surface analysis. And if we are doing the vulnerability study, we are interested in both infrastructure movement, but also the ground movement over time.
Thank you, Mihaela. We have time for more questions. We are in time, so please.
I would like to ask about, I don't know, maybe you do not have right now a lot of results, final results of the subsidence. If you have, can you tell us if in Bucharest you can validate? Because I know you need to at least to validate with the measurements made by GPS.
We have in this project, we also have GPS measurements. So we validate the PS analysis with GPS measurements, and then because the small baseline subset is obtained more recently, we cross-validated with the PS analysis. So this is why we wanted a good cross-correlation, because we also have the GPS measurement that we use for validating the PS analysis. So,
which is the rate of subsidence?
Well, it's not very big. It depends, of course, on the area. But yeah, you can see it here. It is mainly between minus 2.5 and 2.5 millimeters per year, which for urban areas is not very big, so we don't have a big problem. But it can be used in geological applications to depict maybe trends for a larger time scale, but not an immediate problem.
You should also need to correlate with the geology.
Exactly. If we want to make a geological analysis, we don't have a problem.
Nice one. Thank you.
Thank you very much. We have some time for more questions. Yeah. If they are not, we stay in Bucharest, but we go on a total different topic. And I invite PhD student George Stecoreanu from the University of Bucharest to give us a presentation about multi-scale analysis of Bucharest GDP on a not-free scale.
The structure of presentation, abstract methodology, result and school discussions and conclusions. The economy of Bucharest framework scale analysis is one of the most one of the most representative correlation of the relation economic analysis was based on a different criteria independent criteria situation. The European Union, the country which formally had a central effect in the economy and Romania. The research was based on the identification of those areas in which the GDA had a great impact over the GDP. Okay, the basic idea of this is represented through regression. Y is B plus beta multiplied by X plus epsilon, where Y is definite variable, X is indefinite variable, B is a constant, beta is slope, epsilon is resistance. Y indicates that there is a set of coefficients estimated for every observation in our data in general analysis. The geographically related regression is a local statistic, a technical statistic, used to analyze the spatial values in sphere of the spatial relationship. That is incorporating definite and historical values. Also, a good characteristic which we can find in the language. The table we choose in a decent manner is for a pixel distance and in an adaptive manner. Used in a special context. For example, the number of neighbors. The logic of the analysis, the implementing of the regressions will be represented through standard deviation. Standard deviation displays the distribution of the given value which are usually around the average. Okay, and the most important logic is the connection between the GPA and the GDP is issued through the OAS, which model a strong global relationship. While the GDP explores the local relationship and also those relationships really are. The first map is the distribution of the residual from the linear regression between the GDP and the GPA in a mass sea level in the European Union. It represents an estimation of how much the and variable will change if the explanatory variable modifies. The years were in this case is 0.7, which means that it estimates how much is the GDP explained to the GPA. In our case, it's very clear that 70%. It's a small number, but it's a large area. The distribution of the geographically weighted regression between the GDP and the GPA. I choose the Kenya type adaptive and 30 neighborhood as that neighborhood. S-square is 0.75, a value which increases the proportion of the variation to the dependent variable, which is represented through the regression mode. The highest value can be found in intensity, Stockholm, and the opposite side we find Athens, Warsaw, Paris, and other capitals. The smallest or the biggest standard deviation is the higher of the lowest impact in the GPA over the GDP. The distribution of the residual from the linear regression between the GDP and GPA on sea level is the state which formally has a central economy. The S-square is 0.61 in this case, which in a simple regression for a single explanatory parameter represents a success. The capital where the GDP is higher, that the interest are high, bigger, and and the opposite side is larger than you guys, minus 2.1. The distribution of the geographical weighted relation between the GDP and GDA on a sea level in the state which formally has a central explained economy. The capital type is adaptive was 30 neighbors now it's 0.74. The positive standard deviation are encountered in Bratislava, Tallinn, and Riga, and the opposite side is partially Italy and Sofia. The distribution of the result and the linear regression between the GDP and GPA on a mixed level in Romania, as well now is 0.64, is demonstrating the great impact of the GPA on the GDP. We can see how the highest positive standard deviation appears in the country of Ipo, Finnish, Arab, and Krishna-Boka. And the opposite side is strong negative standard deviations in the country of Austria. The majority of values with a negative standard deviation can be found in Moldova, Kenya, and Tanzania. The distribution of the geographical weight regression between the GDP and GPA on a mixed level in Romania. The Kenyan type of this time speaks, given the fact that we should take into account special units in the same time. X square is 0.67. The highest value can be found in the country of Ipo, followed by Constanța, etc. Negative values of standard deviation can be found in Bucharest, Iași, Maramureș, Zău, Vol, etc. These values are translated positive ones are usually encountered in the west and in the center, while the negative ones are found in the east and south of the country. Okay, in conclusion, one can see how the relationship between the GDP and GPA is dependent across the studied area, and the influence of the GPA in the local economy, especially in the comparison between the GPA and the GDP, through some standard deviation obtained through the OAS analysis, and then FBRF analysis demonstrate the hypothesis of this study. The added value can be obtained through some qualified workforce. That is why the economic resources have to be specialized in training people.
Time for questions or remarks? Any questions? The next paper will be about an interactive map. How can the GIS used as a tool for informing and monitoring the implementation of Romanian transport infrastructure project? And I invite my colleague Robert Dobre to give us this presentation.
Thank you very much for the presentation. Good afternoon, everybody. My name is Robert Dobre, and together with Laurențiu and Cuțan Netcu, we have an agreement with the Transport Ministry in order to finalize the Romanian National Transport Master Plan, and we intend to use an interactive map in order to monitoring the implementation of the Romanian infrastructure projects. So our goal is to create a complex information tool which would provide the data, the information for all the beneficiaries for the projects, CFR, National Road Company, European Commission, or local authorities, and would use for this research the General Transport Master Plan project. Some words about master plan. Master plan refers to the main projects of the national transport system in Romania, and the planning horizon is the year 2030. Romanian General Transport Master Plan provides information such as economic efficiency, sustainability, safety, environmental impact, and also the implementation strategy. In first step, we define the project identification. We've done this job to identify the best pattern which links the main cities in Romania. In the second step, we established the cost of the investments for each project using the standard cost. Standard cost defined by the relief sectors. For this research, we use some information from different countries from Europe, and together with experts from Jaspers and European Commission, we defined the Romanian standard cost for roads projects. As you can see, the cost of the projects are lower than other countries in Europe. For instance, in step 3, we determine the length of the relief sector with GIS tools. In this case, we have the Comani-Brașov motorway project, and we defined the relief sector, and together with the standard cost, we established the estimated cost for this project. So the final cost, 1.2 billion euro, it's calculated with different sectors of relief. After that, we use this cost, and together with the data, with the transport data, with demographic data, and with economic data, we and in this national transport model, which is a GIS application, we obtained the economic performance indicators for each project. These indicators are net present value, the economic internal rate of return, and cost benefits. After that, we generated the project list, which was sorted by score, in this case for motorway projects. And also we define the implementation strategy. That means when and with what money we can do all the projects. Also, we create a database which provides information such as the route of the projects, the technical information, and the physical stage of the work, financial progress, and the payments performed. Also, in this platform, you can find GIS resources and maps and situation plans. We use CartoDB, the free version, and here you can see all the projects from General Transport Master Plan, in this case for road sector. With green, there are motorway projects. With red, there are national roads, and with yellow, there are European roads. All the projects from the master plan. Here, there is an example for Pitești-Sibiu motorway. So you can click and you can find several information. And for each project, we have a project page with several information such as description of the project, contact data, map of the project, information about the feasibility study or the consultants, the terms, the study of the project, and also some geological and geomorphological information with critical sectors and the solutions for these critical sectors. Also, in order to monitoring this project, we have information about financial studies or physical and evolution studies of the project. We intend to insert all these data in ArcGIS online platform, and also, as maybe you know, the General Transport Master Plan now is in the final step, the laws approval. Thank you very much.
Time for questions.
The application is public now.
No, in this moment it's not public yet because we need first to we have the law approving, and after that, but the information are public. The master plan information are on the transport minister site.
And when do you think it will be
In this year, we are hoping
at the end
in December, the end of December, the application will be public.
and everyone
Yes,
can
yes. This is
know
the
this time?
goal of the main goal of this project, to inform and to see the study of the whole project.
Very interesting.
But we wait to see all of it.
Any other questions? Discussion on this idea of GIS as a tool, an integrative tool. We stay in this topic with the next presentation. We talk some about GIS used in educational purposes. And I invite Mihai Nicoliță from the Faculty of Geography, Alexandru Ioan Cuza University in Iași, to present new GIS geodatabase named GeoEduGIS.
Hello everybody, I want to present you joint work between members of the Geography faculty and members from the Computer Science faculty. We are working together in a project. The project is dealing with the text recognition methods in geographical text works and their mapping on their transferring them on maps. In this context, we have an idea. Our project involved let's say, the project is called Mapping Books. So we want to map a book, and we have one study case which is related to manuals. So we believe that our method could be used in creating digital manuals. But in this context, for example, if you map a book which, let's say, explain only travel between two cities, it's quite simple to show that travel distance on a map. But in our case, since we are dealing with applications and with rather complex data which need to be represented on maps. Our idea was to create maps, actually to make the maps from a manual interactive. In let's say, to arrive to such a target, it's clearly that we need a database, a geodatabase. We need data to be able to show this information online. And the main problem with education is that you need simplified data. Data need to be, let's say, at least open and free, because, as you know, in education there is not a lot of money investment and so on. So our idea is dealing with specific relations between GIS and education. For example, we target the use of GIS in teaching geography, also the geospatial data and the geospatial technology, the interactivity, because the GIS maps can be interactive. Also the self-learning, we target the use of those maps by the students, by the pupils in their spare time, not only, let's say, during the class. And also nowadays there is a lot of ideas about the increase of spatial thinking skills through GIS and geospatial data. But as I told you, the main target is the creation of hypermaps, which represent interactive maps from which you can get a lot of data from other sources. So the hypermaps are actually all the web maps that are nowadays available. When you click a certain point, like the colleague Robert presented, when you click a map, then you get a lot of information which is not necessarily geospatial, but it complements the geospatial information. So these are the objectives. Unfortunately, I cannot present you a working state of the database because we had problems with the server. It came 2 weeks ago, so we still are working on the final server, but we have tested on local in the local approach. So the idea is that in this project we use this geodatabase, but this geodatabase can be used in further applications. So it's open up to any other GIS implementation in teaching and in education. Not only in geography, but also in other areas, history and so on, where you need a spatial context. And our target is not to learn, to teach the students or the pupils GIS. The idea is to use GIS in the requirements, for example, the national requirements for gymnasium, for high school or higher education. About the data, we had to use all kinds of data. The main idea is that for education, you actually need to process that data. Sometimes you need to generalize. Sometimes you need to add other features to data which is already available. For example, for global and regional data, as everybody knows, you have a lot of sources. For a national scale, and you will see that our study case is based on the manual for the 8th grade. We have some problems. For example, we need to use the Romanian atlas, which is quite old, so we need to work to improve, let's say, not only the resolution, but also to update the data. About the technologies, we have to use open source technologies, but they are quite easily to implement. So we will have data which will stay in a geodatabase, PostgreSQL with PostGIS, and the geospatial server which will serve the data will be GeoServer, also through GeoWeb Cache. And then the final product will be available, let's say, in a browser, but this browser can be included in any other desktop or mobile applications. As a study case, I told you we have used the 8th grade geography manual, and we have to use the following data. We have used them, and I told you in specific cases we had to generalize a lot and to include other information which was required in the manual. I will give you an example. For example, you have here the landform regionalization proposed by POSA in 2006, and here you have our, let's say, generalized data set which include only those locations which are required in the curricula for the manual. So in conclusion, we present an idea of creating a geodatabase which would be free, of course, because the license of the free data requires you to also forward data, the free access to the data. Also, the data need to be modified, generalized, analyzed in order to fulfill the educational requirements, and generally will be presented as a hypermap, but it will also include other processes. And it's clear that the use of open source software is required also, and we believe that our approach can be further used for creating free e-manuals, free e-books. Thank you.
Thank you very much. If there are questions, remarks on this way of learning, please.
Hello, my name is Christian. I would like to have address you one question regarding one of your last slides that referred to the forms of already that one. What is the data source for this?
So the data source for WhatsApp 2006, it was the data from geospatial.org. And here we have actually merged a lot of subunits, and then we have to redraw some of them. So it's a free data if you know it from geospatial.org. The landform delineation.
Any other questions?
Yes, as I told you, we have done the work on a local network, so we have all the data inside stored, and all the services working, and now we need to replicate it on a public server. And we have some setup. We need some time to set up all to be publicly available. Yes. We will have a website. Who is interested? I will give you my email, and then I can deliver the link with the website and the server address to be used.
Any other questions? If not, I'm also wondering how do you use GIS and self-learning in your department, for example, if you.
So the idea, as I told you, is not to learn the students' pupils, or let's say the students' GIS, but to use GIS tools to create data for them to think spatially in an advanced way.
Can you give us an example?
For example, GIS now it's a science. For example, when you simply do a topographic profile, not in a classical way, in a modern way, in GIS, you use GIS. So we will use GIS in creating maps, topographic profiles, and other information.
During the class or?
No. The GIS inside the system. It will not be used by the students. They will not use GIS, but GIS products. For example, a web map, up to a certain point, it's a GIS derived product.
When will this function in your?
But the geospatial data will be freely available, but the system will be done only for the 8th grade. The mapping book system, it will have a study case. Theoretically, it can be adapted to any manual, any book, but it will be available only for the 8th grade book manual. But the data behind will be freely available for the others to use it, and also the system.
Thank you very much. Any other questions? The last two presentations are on the topic of wildfires, and I invite Bogdan Mihai from the Faculty of Geography, University of Bucharest, to give us his talk about wildfires at the national level.
Okay, thank you very much. Okay, I would like to use the microphone. I think it's better. First of all, we would like to make a presentation about the project CIAPIM. You can see here the emblem of the project, which means satellite image analysis for fire monitoring. Of course, this was our idea when the project started in 2012, and then we discovered that GIS can help us much more than satellite image analysis. And first of all, we would like to say that this is the first Romanian project focused on wildfires. This is why we try to learn from other schools which are more developed, they have more experience in this domain. But of course, we want to present the main results of the project, and also Mrs. Maria Vișan will present the practical side of the project, because the output of the project was also a practical output, which is important to be prepared for the interested specialists. So this project was financed within the Romanian Space Agency competition, which was organized in August 2012. And a part of this project, a part of the funding came from the European Space Agency. So this is a project, in fact, focused on Earth observation, but together with GIS data and field expertise, we tried to produce the first maps focused on the susceptibility of our forest to wildfires. Why this project? Because at that time, probably everybody remembers from newspapers, but also from electronic media, a lot of information about different fires in our forest. So these are only some photos. This is a photo from a website from Apuseni Mountains in March 2013, where firemen, together with local people, they tried to control the fire spreading in a pine forest. Next, you can see a photo which was done by Ionut Săculescu, our colleague, in Cotia Mountains. This was during our field trip with our students in May 2013, with the forest which was affected by fire in the month of August 2013. And you can see from a newspaper this photo with the top of the Cotia Mountains at more than 1,600 meters of altitude, affected by wildfire. Then we can go also and look to Google Earth. Everybody knows Google Earth, but it's interesting to check some points where wildfires were reported in the media. For example, Suran Mountains, where we had a very interesting situation in November 2011. This image is from August 2012. But in November 2011, after a dry autumn like now, like this period, there were wildfires in Suran Mountains to the springs of Sebeș and Lotu rivers.
So you can see also on this natural color image from GeoEye satellite, this area which was affected, very close to the timberline. Then on the Latorica Mountains, Latorica, a tributary to Lotu River, in southern Carpathians, a similar situation. So our approach was focused on finding what happened. But first of all, an argument can come up right from the European statistics about this phenomenon on different states from the European Union. For example, these are two graphs. One of them is economic losses due to forest fires in Romania between 1986 and 1999 from the GRC and the Directorate General Environment. And you can see European statistics. And also you can see here there were some losses, economic losses, which were evaluated in thousands of euros. And of course, the graph continues with the 2000-2014 period where the losses started to be more or less higher. You can also notice the trend line here and here. And this is a subject which can be interesting, although everybody knows that the Mediterranean region is typical for this phenomenon, like in southern of France, like in Italy, in Portugal, in Greece, or Turkey, or Israel. So we tried to see what is happening here in Romania. So one of the steps we did was to try finding some data about this phenomena. Of course, we tried to contact the Romanian General Inspectorate for Emergency Situation, the IGSU, which is the authority which has a database of these events. But this database is not a very accurate database like the Spanish government database is. So the problem was that we obtained a statistic at the national level, but also we obtained a statistic to department levels on administrative units. Ionuț Săvulescu did a very good work because he tried to do this general statistic, and you can see the number of events which were reported, but you must know that these are only the reported events, which means much more than 1 hectare, I think, or 2 hectares of vegetation, of forest vegetation, which was affected. So there could be also other, but we still have a lot of photo. This photo is in a subalpine mountain zone, mountain belt, and you can see that bushes in this area higher than the timberline. For example, in Iezer Mountains in southern Carpathians were affected. This is the number of events, and you can see the number of events decreases, but it's important to see that the surface of forest stands affected started to try to increase. So you can see the trend line of for this period, because the IGSU had a database limited to this period between 2000 and 2014. Then we tried also to see other statistic features of these data sets. For example, Ionuț calculated an average wildfire affected surface per event in Romania for this period. So you can notice here with light green the average surface affected by wildfire per event and the average surface affected by forest fire event. So it's different because the wildfire also can affect also some agricultural areas, some pastures, for example, or hay fields, some gardens, for example, but it's different situation because we have also wildfire affecting forest patches. Our project focuses mainly on forest because forest has also an important economic value, but also is the ecological value of the forest. So if we think about the services of these forest ecosystems, we can understand very well why this phenomenon is important. Somebody can ask, okay, but it's temperate region. It's no problem. There are humid areas like mountains or hills. No problem. But we just discovered that this problem is a risk factor which can affect us and affects us more and more. This is the statistic which is behind the graphic representation. This is the annual distribution of forest fire affected surface in Romania. And this is important to notice that the month of March, for example, you can see the average number of events is 28.9. The month of April, 20.2. These are spring periods. So it is interesting because we usually know that in the month of March, snow melts and the air would be cool and humid. But it's a very interesting and a little bit strange situation to be explained. Then it's of course the month of August, where we have a lot of reports in media. In newspapers, on the radio and on television, we can hear this month during the holiday months. There are events reported in different parts of the Carpathians, for example. Then you can also notice here the annual distribution of wildfire events on forest fire affected surface in Romania. And this is the peak, the month of March, and the second peak in the month of August. It is strange a little bit, but we try to explain and to correlate this data in order to find a logical scheme of this analysis. So, few years ago, for another paper which was published, we did the processing of meteorological data for 3 weather stations in around Desert Mountains in southern Carpathia. This is Câmpul Lung, the hometown of Ionuț, 681 meters. Undata, which is in the Grand-Rupert corridor, one of the highest villages in southern Carpathians, and the Obu Peak, which is the highest meteorological or weather station in the Romanian Carpathians. So this is the trend line showing the general trend, like we can see also for other weather stations in the Alps, for example, in Central Europe. But this can explain that something happened. So this could be an explanation, but this is an explanation which has a limited argumentation. This climate change. So it's important to continue with this, but this wildfire analysis is only one approach of the approaches to be done. This is a spatialization on 2 maps of this phenomenon. So this is the wildfire site statistics on administrative units. We have these Județ, the counties of Romania, and we observe this southwesternmost part of Romania with Mehedin, Gorj, Vâlcea, and Hunedoara counties from the IGCU statistics, which reported the biggest number of events. So, if we think about the geographical features of this area, it means that we have also a part of the Romanian Carpathians here. These are the southern Carpathians, the Banat Mountains, and also the southern part of the Apuseni Mountains, and also some plateaus like Mehedin, Georgetic Plateau, and hills in the Subcarpathians, and also the depressions. So, theoretically, it could be a more or less humid area. But, of course, you can see photos. Something is happening there. This is from Mehedin's mountains, I think. I don't know exactly. And other area in the southern Carpathians. Of course, I think more suggestive is this modeling using the density of these events. So you can see a point means one event, and you can see here high density here. The highest density is in this area of this department. So the highest each point represents an event. So the biggest density is here, even in mountain areas, which is a very interesting situation. I don't want to pass exactly here, but we would like to give an explanation here, because from the literature, everybody knows about the southwestern or the sub-Mediterranean influence upon the climate in this area, because the air masses, they are coming from Serbia and Croatia, from the Adriatic Sea, crossing the mountains before arriving in this area. And so this is an area which suffers from drought in some periods, because also there is also the Phoenix effect of the winds coming from Central Europe and Western Europe and trying to cross the Western Carpathians here, the Apusen Mountains and the western part of the Southern Carpathians. So we would like to make a connection between this density of wildfire events and the Phoenix phenomena from the month of March, which is typical for some areas, like we know, and there are also recent findings in this subject. We tried to propose a scheme of analysis. So for image analysis, for satellite image analysis, we discovered that these are much more useful in order to map and to do an inventory of the burned areas, much more than to integrate them in a specific analysis. But a GIS analysis can help in order to calculate the susceptibility for wildfires in the Romanian forest. And together with my colleagues, we tried to do this scheme, and it was developed in a model builder of ArcGIS. And this scheme has two parts. This part means the calculation of the static susceptibility. So the static susceptibility for wildfire means the susceptibility related to the morphology, also to the forest stand features, and also to the soil layer. It's important to talk about the soil layer, because a lot of the papers published here in Spain, in Portugal, in France, in Italy about this subject, they neglect this factor. This is objective, more or less, because in Spain or in Greece, probably, if you go on holiday, you can see this, or in Sicily, or Sardinia, or along the French Riviera. You can see that the forests affected by fires are especially on bedrock, and the soil is not so thick. But in Romania, the situation is that you have more or less continuous soil cover, which has to be analyzed in detail and reclassified in order to obtain data that can help the calculation of the susceptibility to wildfire. This is the static susceptibility. Of course, if you have some questions, we'll explain what we did here, because we did the vector data input, also the transfer to raster data, and then the reclassification and the processing of the rasters in order to create this layer, the final layer of static susceptibility. But on this background, we had also to take into account very much the dynamic factor. It is about the climate, and because the climate means quite a lot of things, starting from temperature, precipitation, humidity, and other, we selected one index, which is the old and traditional Marton aridity index, which includes also temperature and precipitation in the same formula. And we calculated it for each of the months of the year and reclassified it according to some conditions in order to obtain the dynamic susceptibility layer. And then also we crossed these layers, the dynamic component with the static component, in order to obtain a vector of layer susceptibility. There are some operations, mathematical operations we did here, because first of all we had to reclassify temperature and precipitation, then to calculate the index for each month, and then the average of the index. So for each month of the year. We continue, and this is what means soil, for example. My colleague, which is specialized in soil geography and pedology, put the emphasis, and we discovered that soil is an important factor, because it depends also on the adaptive volume. If you have a soil with bigger depth, it's probably to have there also organic matter, but also clay. And this clay controls very well the process. So if you have much more clay, the susceptibility can decrease because clay means humidity. It's a more or less humid microclimate in that forest stance. These are some examples. In the same area, it means the Mehedis Mountains, the Domoklet Mountain, which is also natural reserve. My colleague did some photos here, and this is the situation of the typical Renzina soil, which has more or less also organic matter, but also it has also some clay. But also this is also the situation of the trees of the pine, Pinus banatica, on the bedrock. So these are the soil types, and this soil database coming from the Institute of Pedology in Bucharest and Agrochemistry was updated according to the newest classification system by UNUS. And also we tried to classify and reclassify this data in order to focus on the soil which are more exposed to which have a bigger contribution to wildfire and a lower contribution to the wildfire. Then it was the database from the Institute of Forestry. The map of forest stands in Romania was reanalyzed and processed, and we also tried to classify and separate the species and the stands which are more exposed, more vulnerable to wildfire. So the highest vulnerability was observed to be related especially to conifers and mainly to the pine forest, as we did also in some detailed researches in the Domoklet area, which were carried in 2014. You can see also photos here, which can show also Picha excelsa or spruce fir stand affected by wildfire. Then we also integrated in the relief, in the morphological layer, we have integrated an important factor, which means the insolation index. So we tried to integrate also slope declivity with slope aspects, which were reclassified after making a cross operation between them in order to obtain the degree of insolation of the slopes and of the surfaces. So we consider that the sunny sides of the mountains and of the hills and the most exposed to the sunny with a lot of hours of sunny exposure are important for the calculation of this index of forest fire susceptibility. So this is the insolation map, and this is the layer which puts the emphasis on the geomorphological condition. And this is the statistical susceptibility obtained. So what is interesting is the highest values are related to this area in brown, and the lowest are the area with green. Of course, the white area means that there are no forests, because we focus mainly on forest stems. Then it is also the dynamic component of forest susceptibility, which is based on the monthly dermatol aridity index. So for each of the months of the year, we have created a grid of this dynamic component of susceptibility. This is the formula you know. We integrated in the same formula average monthly rainfall and also the average monthly temperature. These data were taken especially from the WorldClim database, and it was also validated with a lot of data from our weather stations, because about WorldClim probably you know, these WorldClim grids come from the meteorological data from International Meteorological Organization from Switzerland, and they were afterwards calibrated with in situ data, and then they were used and reclassified as grids. And this is what we obtained. This is the month of January. So this is the forest fire susceptibility for the month of January. Green means that the forest fire susceptibility is not so important. The month of February, March, and you can notice that in March, April, no, March, I will try to say here, sorry. Here there are some classes which occur here. Unfortunately, the map is quite small here on the slide, but we have the map of the high resolution, and you can see these new levels which occur, especially in this area, southern part of the southern Carpathians, western from the Old River mainly, and also southeastern part of Apusen Mountains. April, May, June, July, and you can see also in Dobroja region here something, and August, where we have reported here events, quite a lot of events, not the biggest number of events, but here in the month of August we have the largest surfaces affected. So this is the situation is important here in the southwestern part of Romania, also in the southern part of Oltenia where we have forests on sand dunes. And you know about the sands are very permeable and the conditions for wildfire are important. This is the month of September, October, November, and December. So, we have this synthetic map here of the events you can see with these round points correlated with the area of high susceptibility. And you have the map here on the wall slide. You can also notice this this map. On this map you have also the event, and there is also a mark which is related to only to the month of March. So only the events reported for the month of March are on the map. So you can correlate them with the brown patches or dark yellow patches here. And you can see the concentration to the southern part of the Carpathians and southern part and southeastern part and eastern part of the Apusen Mountains. There are some explanations related to the current phenomenon. So these islands with reddish color and these vectors can explain the situation of the air temperature during the month of March. These are from a colleague from the National Administration of Meteorology, Anișoara Iordache. She did a very good thesis focusing on the firn wind in northern Oltenia. And then also we can see the events from the month of June, which is the beginning of summer but is the end of spring, a period where in the Carpathians, in the Subcarpathians, we have quite big rainfall. The month of August here, you can see these patches here. Banat Mountains and southwestern part, and also the events by stars. And also, this is a comparison with a lower scale synthetic map did by the European Directorate for Environment. So you can see the situation in the whole Europe at that time, southern Italy, Sicily, also Sardinia and Corsica Islands, central Spain, the Meseta, and also southern Greece. But also Bulgaria could be also interested. So you can see also these colors on the Romanian territory here. Yes, in detail you can see also the Romanian county limits and some areas which are more or less related to the plain area. But this map, you consider it more or less wrong because they didn't took into account in a separate way the wildfire regarding forest and the wildfire regarding other maps. The validation was done at a more detailed scale. This is a part of another work we did. This is, of course, the same map you have seen. This is a detail from this map with the Cherna Valley, also Mehedin's Mountains here, Cherna Mountains and Banat Mountains. And you can see also the areas which resulted to be with the highest degree of forest fire susceptibility. This area superposed more or less on the pine forest, especially Pinus banatica, which were mapped here on a Pleiad 1B ortho imagery, which was done 2 weeks later than a big event, which was in August 2013. This image at 2 meters, it's obtained after an image processing. So we wanted to make decorrelated data here because on natural color combination or color infrared combination, it was more or less complicated because we had also shadows there. And this is an area, you know very well, this is Baile Herculane resort here. This is an area with, which is developed along a tectonic graben, and the steep slopes can also affect the quality of the data. Of course, I will finish. Conclusions. Wildfire in Romania was considered for decades a secondary natural fire. Forest fires were in the center of our approach because of the economic importance in the context of economic loss, also affecting infrastructure as well as natural and national parks, including Natura 2000 sites. We wanted to speak more, but we have enough time. But this site in Baile Herculane is also a Natura 2000 site because the Pinus banatica is a protected element, a protected geographical element, which is one of the most affected forest species by fire in our country. Although the study area is included in temperate climate region, forest fire occurrence is a reality, not by an increasing number of events, but with the enlargement of forest stands affected during the recent years. Wildfire events are the most frequent in the months of March, turning influences on the outer slopes of southern Carpathians and Apusel Mountains, and August, dry episodes in the context of local and regional climate features. The area with the highest susceptibility was mapped using GIS application in order to map also the static but also the dynamic component. And also the analysis confirmed that forests from limestones, conglomerates, sandstones, sand, gravels, etc. It means high permeability rocks where litter is continuous are the most susceptibility to wildfire. This is the case of southwestern part of Romania with some Mediterranean climate features and of the eastern part of the Apusel Mountains. Thank you very much.
Thank you, Professor Bogdan Mihai, for this very interesting presentation. And I'm wondering, what do you think? Would be wildfire a problem for Romania in the context of climate change?
I think yes, because, for example, there are some colleagues from Serbia which published recently in Ljubljana a paper which speaks about wildfires in Serbia and Croatia. And some events were also reported at a very low distance from the Danube river gorge on the Serbian sector. So also we discovered also that the Bulgarians are also interested in such a phenomenon. So I think it's a phenomenon which can be taken into account in means of analyzing the losses in our forest. For example, Ionuț can tell you much more about wind flows, because storms affect also the forest on the slopes in the mountains, and for a long time we believe that natural hazards affecting forests are related very much to wind flow and also to snow flow. These were for a long time, but now we have to take into account this aspect, and making a correlation of these results with other results and with the deforestation in some area, we can have a broader image about the forest stand losses in our mountains. Because everybody knows For the Carpathians, forest and forest stands represent an important part of the landscape, the essential part of the landscape. I think they are mountains which are different than other mountains in Europe because of this part of wilderness. Of course, Carpathian forests more or less are a lot of secondary forests there, but also these secondary forests have to be preserved.
Could you say also something about the nature of these events? Are they human induced?
Of course, it's a very, very important. Thank you for the question. The factor involved is the human factor, because of course climate is important. But for example, during the month of March, it's traditional in the month of March when winter ends to go outside the village and try clean your parcel there, and also to put fire in order to clean your land over there. And unfortunately, we are a country affected like other countries by an important rural depopulation. Old people and skilled people, in order to control this wildfire to the edge of the village or of the town, are not so much. So there are a lot of situations that the phenomenon can be out of control sometimes. It happened also this summer, 2015, by the Herculane, and together with our colleague Professor Emilio Ciubieco from Alcalá de Henares, which is one of the renowned specialists in modeling this phenomenon, we discovered that only neglecting the situation and the interface between the town and the mountain slopes, you can help the spreading of wildfires.
I have a small question. Why didn't you use the statistical model, since you have the location of the wildfire and you have all the layers factors? Because you say the soil is important, but I do not see how. There's usually clay. Okay, it has some water, but usually it's physically inside the crystalline network, and you cannot say that where you have clay, you necessarily have humid area.
Ionuț will explain much more about
During the coffee break.
during the coffee break, Ionuț will explain.
Have one more.
The events were important because for us it was a validation also of our analysis.
One more,
Yeah,
short,
just
very short.
have a comment or comment.
For a comment.
Usually the location of the wildfires are a bit random because they are humanly induced. And the wildfire occurs is not a natural one, especially not in Romania. Maybe in Spain, maybe in California, but not in Romania. And that's why if you do the model, most probably you are not going to have more statistical significance of the different factors. Especially because the location is random. We have forests everywhere, we have the base slope, but where the fire actually occurs is related with the human presence. And my question to Bogdan is, if usually you go and there is places where people are going outside, stay out and just open a barbecue or something like this. The question was, have you tried to use a physical model in order to have a map of the fire intensity of the fire spread using the fuel load, different time periods? Because there are models that take into consideration the fuel load, but the small vegetation, forest, ground, and it is possible to generate a fire spread map or a fire intensity map.
Of course, the project was focused on a national level scale, because this was our intention to produce the first map. Of course, we did also details analysis, but it's in another presentation in the area of Băi de Herculane. The main problem is the modeling of fuels is not so simple, because there are a lot of models in the literature. But these models, we discussed also with our Spanish colleagues, are very difficult to be applied here, because most of these models were developed in Mediterranean area. And we try to find an indirect way to include this factor. For example, soil together with the litter, which is created by the forest vegetation, can be important. Of course, another problem also about the event, and Mihai also asked very well other things. The database was was not a map. It was based only on a tabular database. So that event you have to take into account because most of them they were reported on administrative units. But Yunus, he tried to use the Google Earth data in order to put in the right place, in the right point this equation. And this is why we consider that to the interface between the settlement and the forest of the agricultural land, there are areas which were affected during the month of March, for example. Okay,
Please keep the more complicated questions for the coffee break and just a very short one.
It is actually related to your comment. There are several nationwide fire data robotics, NOAA,
yes, we know.
you consider using them to refine your results from data. You already have the geographical.
Yes, we know it's a colleague from Alcalá de Henares, Steve Hanson, which validated the Mountain of Environment Journal this product. Of course, you know much more than us. You know very well that some quite fast in terms of resolution. But this database with fires, with hotspots, it's called what is hotspot, this database, is not every time suitable because I discovered it includes also some points where we have lightning and also some fires probably around the shipwrecks on the top of the mountains during summer. I observed flying from Paris to Bucharest, for example, by night, there were fires which can be also seen by different satellites from the top of Barren Mountains or Kapatili Mountains. This can be also included there. So you have to refine this data. It's good for validation for larger surfaces, and especially for regions where the phenomenon spreads very much. I think so.
Our last presentation is also in this topic. It's about vulnerability and how we can use practical use of these vulnerability maps. And I invite Maria Bishan from Intergraph to give us a talk about this subject.
Good evening. Hoping you are not so tired. I will speak loudly and I will change my voice in order to keep your attention. I'm talking about how we can put GIS instruments on work, because all these scientific results could be, as Professor Bogdan told, could be used more interesting if you can spread the information or if you can process the information more easily. I will go through this presentation. What I want to say is that in our project we use the entire workflow which is kept by Intergraph here in Romania. I mean, processing the images. We have used this type of softwares and also GIS processing. And then we try to publish the information. This means that all this information, this data regarding maps, has been disseminated on a web server. It's not important in this moment because we hurry up a little bit. The project already told Professor Bogdan. I want only to mention that the novelty and the originality of the project was that it was an integrated approach. This means that all the patterns and the multiple chaos has been testing and validating using GIS information, GIS tools. And another important thing is that we try to find in our project how we can apply the results, because we have a lot of customers. I mean, companies who are operating large infrastructures, or we are talking about emergency situation, and also they are interested to manage somehow this type of events. We are talking about public administration who are interested to know everything about fires and vulnerability near their administrative unit. we are talking about Natura 2000 sites, and there was very good examples of that. This means that in many areas, this type of event could affect this type of domain. Based on standardization, on integration, and on public spatial data, we hope that we can help all these type of interested companies or public administrations or other institutions. I just give you an example how Transelectrica used this model in order to find wildfire affects their infrastructure. This means that we take this area which has been affected by fire, and we overlap the infrastructure, and we found the infrastructure which are possible affected by fires. This means that Transelectrica should have a special approach for this infrastructure. And they use this information for operational, tactic, and that strategic level in order to find if there is an alert and they should do something, if there is a threat and they should think on a long term or medium term, or there is a risk and they should do something regarding to their infrastructure. These are a sample of the interfaces from their application. Regarding they receive alert messages, and also they have reports how many problems they have on their infrastructure. We develop a web service. I told you that we try to disseminate this information, and this information is available using Apollo GeoPortal for Intergraph. This means that it can be used only by querying, I'm interested in this area, and I would like to know if there is a vulnerability of fire in my interested area. So we have the idea to discuss with many other companies, and we have found also the assurance company who are very interested in this type of data. Here is the detail for the area which already has been presented. What I want to say is that taking data from different institutions, putting together with the research which has been done in this project, this means that for analyze, for decision, and for feedback, you could have this information available for many fields in any type of area of interest. This is what is very important to know, and this is what it should be mentioned, that this type of institutions which manage soil or vegetation or terrain model or information about meteorological information, these institutions should work together, should use open standards, and should put this data together to help each of us. So I think that using OGC spatial data standards and open softwares, this means that you can use all this information very easily. Thank you very much. I hope that
We have time for one or two short questions.
Is there a public link, public website?
for these services, web services, is not public, unfortunately, because there should be developed this collaboration framework with all these institutions in order to put this type of data and to become public. And some of the institutions do not give this data without any money. This is the first one. The result of the project, yes, there is on our website. I can provide you in the coffee break. I will give you the website because it's public, because it was a project, OSA project, and you can see all the results there.
And the cost of implementation, such a WebGIS system?
Regarding web services or what?
Yeah,
all the systems. It doesn't take too much. depends on where you want to use. Transelectrica, for example, have the entire software and they use only the results, the database, the forest and the soil and everything. In what you see there, it has been used a desktop application, Geomedia, which is not very expensive. We use AirTAS imaging, which are coming together with Geomedia, and we use Apollo, which is a server base which publish web services. 3 software applications. But on this type of approach, we use software as a service. This means that you will pay only the data which you want to use and only on the area where you are interested. You are not paying the software, we are not paying the hardware and everything. You pay only the results which you can use directly in your application. That's from my opinion, is the great idea.
Thank you very much, Maria Vishan. Thank you all of you being here. We have now a coffee break and we will meet here again in half an hour.
So welcome for the second part of the GIS session. My name is Shanti, and together with Mrs. Basinescu, we are going to share this session. We have all changed the schedule. Mr. Romulus to present the paper, and we are going to continue after that with the normal work. So please. Okay, so just have to
Good evening. My name is Costachie Romulus, and I am a first-class forecaster at the National Institute of Hydrology and Water Management in Romania. And also, I am a PhD student at the Faculty of Geography from University of Bucharest, and together with my colleagues, Andreea Mihalce and Andreea Manolache, I realized the paper we titled using this technique for assessment the differences between recorded rainfall from hydrometric stations and radar products in Romania. Radar products are among the main means used in order to estimate the precipitation in real time. Whether radar is a remote sensing instrument that measures the effectivity of precipitation at a given altitude. This value of reflectivity is used next to estimate the precipitation rate at the ground level. Computing the rainfall estimation at ground level generates additional uncertainty due to the non-uniform vertical profile of reflectivity and the conversion of radar reflectivity into rain rates. The aim of this study is that through this spatial analysis to be made an estimation of the differences between the daily precipitation recorded at the hydrometric station from national hydrological network and rainfall estimates based on radar products. In Romania, there are 8 radar products: the national mosaic radar and radar from several locations, from Oradea, Timișoara, Craiova, Bucharest, București, Nedjdia, and Iași. We are attempting to make the first assessment of the degree of uncertainty of precipitations from radar data to improve the accuracy of hydrological forecast and also hydrological warnings for flash floods. We used the daily rainfall amounts of 24 hours from hydrometric stations recorded in the period between June and August this year, and also estimate precipitation amount per 2024 hours based on national radar and the individual radar station which exist in Romania. Also data in GIS format, the national border of Romania in vector format as a shapefile, and the geographical coordinates of the hydrometric station from the national network. As a method used, we calculate an adjustment coefficient data from radar using the formula. We have um, excuse me. Further, we creating in our software a fitness rectangular cells with size of half degree latitude and 1 degree longitude in polygon format. And then we use the zonal statistics for obtaining the final results of the analysis. First step of our analysis was the data processing in Microsoft Excel software. Then we convert the Excel data into GIS format using the coordinates for each station. And it is important to mention that at one location of hydrometric station can be found more than one point, because it is possible for one station to have many recorded during the study period. The second step was to establish the number of recorded per cell, and for this we use the spatial join tool from ArcGIS.3.1. The higher number of records from hydrometric station in the eastern central area provides higher confidence level results for that area. Then we use zonal statistics for assign in order to obtain the minimum, maximum, and median adjustment, median value for adjustment coefficient for each cell of generated grid. And the results here are the first results obtained. After this analysis, we obtained the value of the rainfall adjustment coefficient estimated by radar product, national and individual, for each individual radar station from Oradea, Bobohama, Craiova, Bucharest, Neția, Iași, and Timișoara. The highest values appear at the Craiova, Timișoara, and Bucharest radar, values around 35, which means that the radar station underestimated rainfall values, and the lowest values of the adjusted coefficient occur in the case of national radar product, Bobohama and Medvedia, values around 0.05. Another important product from our analysis is the median of the value of adjusted coefficient. In this case, each cell were highlighted for the value close to 1, where the estimated value is the estimated value from radar is equal to the measure from the gauge station, from the hydrometric station. As shown in figure 15, the values close to 1 are presented in curvature area here, and also in the central north part of the country, of our country. Note that the overwhelming majority of values close to 1 is given by the national radar products. As conclusion, conclusions, since the results are only a preliminary estimate of the degree of uncertainty associated with the estimated of precipitation done based on radar data, it will continue to monitor the differences between rainfall estimated by the radar and those recorded at the hydrometric station. This being necessary to increase the degree of confidence for a large area of the country, as given by the future results based on methodology applied in this study. It's necessary to mention that the two observation systems are generally seen as complementary, and it is useful to combine and use both of them for better representation of the precipitation field. Thank you.
If there are any questions, we have time for 2 or 3 questions. If not, I have one. Are there any plans to make a laboratory service like this one?
No, there's there are no plan. No plan for making an operator.
Another question? If not, we are going to move on to the next presentation, which is actually the first presentation on the list. And I invite you to share the access to my presentation.
Thanks a lot for introducing me. So my name is June Vasilescu. I'm coming from the National Institute for Optoelectronics, located nearby Bucharest on the physics platform. And we are dealing with mostly remote sensing measurements for atmospheric, but not only for these, also for the water investigation. Now I will talk about the atmospheric part. We are focusing on this one. First of all, I want to pinpoint the fact that I'm saying remote sensing and active and passive from ground-based premises, not from the satellite one, but of course they are. Or I'm not. So I can. Okay. So why do you use remote sensing? As we all know, it's usually a harmful situation to use classical methods. It's meaning to interfere with the environment, taking samples and doing a lot of stress and more or less. Okay. So the next slide. Which is the difference between this classical and remote sensing approach. So for the classical part, we are slicing the environment and the samples, and with the remote sensing, we are having a loop from an extended area, and we are just the pure system. So. Okay, so which are the global challenges at this at this point? We are facing a lot of changes, as we already discussed these days. With the climate change and the climate variability, which are mostly pinpointed at international level using both ground-based and satellite measurements. Why to do so? Just because we cannot use only satellite data. These are a good approach for some part of the atmosphere, but for the ground-based, they are quite blind. And one more point, using the satellite data, just to be sure that we see the reality, we should calibrate somehow with ground-based part. So at European level, I'm talking now at the European level, you already know, I think that there are a lot of infrastructures, ground-based infrastructures to look at the environment. These are split in four areas, so for the atmosphere, for marine, solid earth, biosphere, and some overlaps for a multi-domain. As it is easily to see for the atmosphere part, it's quite a lack of such an infrastructure even at the European level and quite important countries. So that one that is one of the key player. It's the active infrastructures, which in the last years put together a lot of small infrastructures like USAR, Aeronet, Elnet, CloudNet. It's easy to see that in our part of the Europe are not so many instruments and observations to be taken into account. So for the atmosphere, it's quite easy to know that you can sense here what your neighborhood is doing. So even if in our country it's not so much pollution, we can have a lot from our neighbors, and we should account for this. So why to do the air quality? Just to know which is the level of pollution, and then we should have a look on the climate variables, which are up, and we should account for observation technology that are good for these purposes. So we need almost continuous measurements and near real-time processing to know in time what is doing, and then to go to space. Why I'm saying this? We already know that we have a lot of satellite data, but for mostly satellite data are for the others players, not for the atmosphere. Atmosphere is usually like noise or byproduct. Actually, atmosphere is interfering with all the measurements that are done from space. We are trying to use the synergy of instruments like our partners in Europe is doing. So we are going for active remote sensors. Or what is the meaning of active remote sensing? This means that we are using a system which emits light, and afterwards we collect the response of the atmosphere to this light and process and analyze the data. And then we use passive remote sensors quite a lot to have a look on the particles and gases also. What means the passive remote sensing? The passive remote sensing it's about a system that are looking at natural light sources like the sun or the moon in our case. Of course, we need also in situ data to validate the remote sensing one, and of course a lot of models and satellite. Why not? This is a graph for the synergy going from aerosols to gases and from in situ monitoring to remote sensing and satellite imagery. Now, just to have a quick look on the type of the data that can be delivered. The first picture is about sun and air photometry. This is the network that is providing this kind of data. You can have information about the particles in the air, like an average on the column from the ground to the stratosphere. And you can say a lot of things. If you have an intrusion, like the dust or smoke, we talked about the forest fires, so we can know if we have such kind of intrusion over the measurement side. And of course, using the network approach, you can trace more or less the air masses and oxidation process in the atmosphere. The lower part is a graph from the microwave radiometer, which gives you profile from the ground up to 10 kilometers on relative humidity and temperature. And these are mostly for the gases. This is an example for measuring at up noon on Robinard power plant. And this is the same thing, but this is for UV part and this is for infrared part. So we are looking at SO2 and NO2 gases in the atmosphere, which they are big trouble in our country. Now let's talk a little bit about active remote sensing. This is meaning LiDARs for us. LiDARs, it's coming from light detection and ranging. So we have a system which emits laser pulses in the atmosphere, and then the backscatter part is coming back to us, and we have a loop and try to do a map with the variability of layers, of aerosol layers in the atmosphere, so we can tell us if we have cirrus clouds like here, or what kind of particles are in this part. So let's go deeper. I will show you several examples or combination of the data. So you should have in mind the last picture, so the range corrected signal. Here is a deeper analysis of that picture. We are tracking the layers. These layers are going down to the ground, so it's affecting us because of what is on the troposphere we are breathing, and somehow it's interfering with us and with the vegetation and so on. So some particles are going down, and we can see here the optical properties of that particles, which gives us insights. So, these are markers that give you insights about the sources of the aerosol and what kind of aerosols are. In this case, it's small. And looking at the back trajectories and at the multi-square maps, we can assess if it's really a small case transported from long-range transport or nearby forest fire. Going in deeper part, these are measurements done at the ground in the same day for the chemical part, and which is assessing the oxidation level and the degree of interfering with our health and our system more or less. The other example that is using the synergy between active and passive remote sensing. So the sun photometry, I said that we have instruments that it's tracking the sun and the moon. So when it's somehow moving around the sky, and measuring the radiation between our station and the last part of the atmosphere, giving the radiance and a lot of other information. This picture is somehow the synergy between the LiDAR integrated information
And sun photometry, so the sun photometry is the red part and the dots are from the LiDAR. And we can easily assess if it's the smoke case or we have lighter dots, and if it's the dot case when we have the darker dots. So for angstrom, really low angstrom exponents, we have dots, and for the higher, we have the smoke. So what I want to point out at the end is like, of course, the atmosphere is interfering with all the measurements that we are doing from the satellite. So we should use this information not just to calibrate the instruments that are on the satellite and are using the active remote sensing. So LiDARs are already on the satellite, but also we can use this to tune our other information that we are taking from the satellite, because somehow the atmosphere is interfering, and knowing what kind of aerosol you have there, you should say more about this. So several applications that can be used using an infrastructure like ours, which I think is good, first of all, because we have a point on the map for Europe, and the other point is that we can say a lot about Romanian pollution level and trajectories and the sources of aerosols in our country. And I think I should go there. So thank you for your attention.
Thank you for the presentation. If there are any questions, we have time for one question.
I have a question about the cost of such a system to increase the density of the.
Actually, for the remote sensing part, so for the LiDARs and for sun photometry, we already have some in the country. So we have one at your university, a LiDAR system and a sun photometer, and one in University of Plovdiv in Cluj, and one in Timișoara. This is true. This means a lot of cost for the active part, because this is a lot of processing data and a lot of personnel that is using that data. But for the sun photometry, it's quite easy. It's a network. It's a worldwide network, as I've already said, and they are calibrated at international level, and then all are processed by the same software. So it's not so costly, let's say, but the outcome is quite good. Okay, thank you.
We are moving to a different topic on high resolution generation, and from that I will go to presentation.
Thank you. Dear colleagues, we would like to make a presentation which is a little bit different than other presentations of this session, because we would like to focus mainly on photogrammetry, on digital photogrammetry techniques, which could be used in the future in order to study the landscape change in Romania. So it's about high resolution landscape change analysis with Corona KH4B imagery, a case study for minor gauge reservoir area. Previously, when we submitted with our abstract to the conference organizers, we wanted to do much more and to focus also on the regional and local scale our paper. But together with my colleagues, we discovered that this regional component can be a secondary component of our presentation, because it's about a new technology with old data, with historical data, because we focused on integrating the data extracted from Corona KH4B imagery from 1968, which means data from the D class 1 database offered by the United States Geological Survey for free, which can be used as a starting point for analyzing the landscape change. Why the Iron Gate reservoir area? Because everybody knows that between 1965 and 1972, in this area along the Danube River, we had important environmental transformations because the Iron Gate dam was realized as a collaboration between the socialist time Romania and the socialist time Yugoslavia. And afterwards, there were some elements featuring for centuries the Romanian slope of the Danube River Valley, which moved or disappeared. Our paper focused mainly on the methodology and on the digital photogrammetric technique in order to prepare data for such an analysis. And at the end of our presentation, you will see that we tested a little bit this data because we tried to compare this data from 1968, exactly from August 1968, with the data from the orthophotos which were realized in Romania by the ANSPI, CPI, which means the Agency for Cadastre and Immobiliare Advertisement. So, we'll start. First of all, I told you that we wanted to integrate both data and show them. But the most important problem was how to prepare from this image frames, from the declassified imagery from Corona KH4P satellite. This means this imagery was classified imagery before 1995, but the United States Congress declassified it and helped especially the Eastern European and the socialist countries in the world because Corona KH4P imagery was imagery from a spy satellite. So after the destruction of the Lockheed U-2 aircraft above the Soviet Union in 1956, United States was thinking to introduce satellite missions with the photographic cameras in order to obtain data coverages for interpretation mainly in a socialist country, but mainly in Soviet Union, because you know a lot of things about Cold War, about the submarines, about airports, military airports, also about military industry in Soviet Union, which was of great interest for the United States Army. So Romania was also a country which was a satellite to Soviet Union at that time. And since the end of the 60s and the beginning of the 70s, this Corona mission, which meant quite a lot of satellites which were launched only for making film frames, and then they were recovered in the Hawaii Islands by some special missions of aircraft or helicopters. So for Romania, there were available quite a lot of images on the USGS website for free. But our interest was first of all to reconstruct the footprint of these two film frames, because these two film frames are not very common. Like we know very well from the archives from the Military Geographical Institute or from the Institute of Geodesy, Photogrammetry and Cartography in Bucharest. We know the classical film frames, which are square frames of 23 by 23 centimeters, for example. These are particular. These are longer frames like this, covering areas like this, and these are superposing because there are pairs here. In fact, there are 4 frames, but these are superposed because it's important also to create the stereo coverage for the area you are interpreting. Especially from the Central Intelligence Agency in United States, they were interested mainly to interpret these images, but not so much to use them in photogrammetric application and to create maps from these images. But of course, this is some part of the cover of the document KH4B camera system. This is the documentation with declassified written here. but it was top secret previously here. So we focus on the problem of photogrammetric processing of satellite images because satellite and aerial images are currently available. The question is how different are these data sets from maps? It is enough to rectify an image using a simple equation, linear, affine, or polynomial transformation, like we are doing currently. For satellite and aerial images, we need enough metadata together with a polynomial equation in order to solve the interior orientation and the DTM of the digital terrain model extraction. Auto rectification is mandatory for scale unification and for co-registering with map. So this step, in order to obtain the same data coverage from the geometrical point of view with our auto photos, is very important. This is, in fact, the key of our research, to obtain an auto-rectified product of this imagery, which had also no projection. Only the perspective projection of the original frames was a feature. Finally, we need to check the accuracy and the reliability of new data sets we produce. So these are more or less the objectives of our research. Then this is the workflow of our analysis. In fact, you have these data features here, and these 4 frames are here, 75% coverage, used AirDAS 2015 and image photogravity powered by Intergraph, and also there were 30 ground photo points taken from the auto photos from 2014, and also from the topographic maps, including also the historical map, which is the artillery map of the Carlo Director de Trage 1959. So, and the technical support was offered by Gizbox company, by Liviu Toma, our colleague and my PhD student, and also by Intergraph. So, what is important was to follow all the stages of a typical photogrammetric, digital photogrammetric process. Then it was first of all, we downloaded images, we recreated the image frames, and we developed a project in order to make the orientation of the images, and also using the ground control points to make the exterior orientation and to prepare also the triangulation of for the study area. So this logical scheme is also here focused on obtaining the digital terrain model, also the digital terrain model enhancement, and the production of the orthophoto using this digital terrain model. So the data, finally, it was also edited because we needed also the radiometric balancing and to prepare the export files in order to introduce them in a GIS environment. So these are the images which were superposed. These were recreated because on the archive of USGS there were in fact one frame was in fact cut in 4 different frames. It was necessary to make a geo correction, and this is the study area. We focus on Orshova, Jeshelnica, Orshova, Fosile or Iron Gate area. So this is what we did. You can see there were separate frames. It's interesting to see also the geometry. This is the original frame we installed, and you can see the date of the images from August 17, 1968, the idea of the mission, because there were quite a lot of missions, and also the image type, black and white, negative, chromatic film, and the spatial resolution. But this is the best in literature, 1.8 meters. This varies because the geometry of the image is a little bit complicated. It's not like our frames, the geometry. You will see later on, and also the dimensions of 16 by 217 kilometers. This is the system work. It was a pair of cameras, one looking forward and one backward. And so you can see the footprint and the combination of 2 footprints, which can create also the stereoscopic effect of this imagery. You can see one of them here and another one here. You can imagine that the resolution of the original imagery is quite complicated notion, because we have one resolution in the center, but other resolution to the edges of the images. There were also some calibration images here, yes, with the line of horizon, which were taken by the special camera, intense camera and solar camera. But the system is described in detail also on the internet, because the documentation is not sequence. So these are the subframes and their features, and you can see also the focal length we have, the altitude of the images were obtained from 156 kilometers. The pixel size when scanning the frame, because they were field frames, negative field frames, yes, the same dimension. This is the orthophoto mosaic we obtained, and we overlay here the configuration of the present day Danube River, including also the Chernobyl, also the full position in the valley. So this can be also very interesting in order to observe, including the Agakale Island, also the dam which was in building at that moment in 1968, and also the area which disappeared because of flooding above the upstream the dam. Next, this is the present day situation from spot auto rectified product, and also you can make a correlation between the present day Danube River channel and also the former, the historical river channel. Then we did also some three-dimensional visualization. So you can observe here also how everybody is familiar with the Chernobyl today, but at that time we had also a quite large floodplain of Chernobyl River and also the first 2 or 3 terraces. So you can notice here the old Orshova and the new emerging Orshova town which was building at that time, because it was necessary to move the population from this area to this area. Also the moving transport infrastructure, the railway also, and the main road. Then this is also the Agakale Island, you can see over there, but we have also other models with the island, and also you can see some rapids of the Danube River waters, on the Danube River waters, and also the area which was entirely under transformation here, you can see. This is a panchromatic image, so it covers especially the visible spectrum. And then you can see also from other perspective the old city of Orshova and the new city emerging to the foot of the hills. Here you can notice the problem of the landslides which were on these slopes, because at that time Orshova was on a site which was more stable than the present day site. And the famous Agakale. Agakale, for our colleagues coming from abroad, means a small island on the Danube River which now no longer exists. But here it was an interesting fortress from the 18th century, because here it was the border with the Austro-Hungarian Empire for a long time, but also a Turkish settlement which also disappeared. The Turkish population left this island at the beginning of the 70s, and they had the right to return to go to Turkey or to be integrated with the Muslim community in Dobroja. But this is one model. The other model could be obtained from other images. This is a provocation we discovered, because the Royal Air Force from United Kingdom, they had a collection on this area of photos, which can be also used. This is 1984, which can also be used. But Liviu, which is my PhD student, he has to make also a new photogrammetric process with these images. This is a map showing the transformation. We didn't realize. We didn't develop the statistical analysis of the change. Why? Because I think it's not so relevant for such a small area. But it's a qualitative analysis in order to superpose this vector focused on the Danube River channel, but also on the roads and railroads and the settlements. Now, I would like to finish, but this is one of the core parts of the paper. Why? Because this is the scheme of the aerotriangulation, which means the building of the exact geometric model of the photogrammetric frames assemblage. So Liviu used also together with us 26 points which were followed on the present day orthophotos, and also the data, the elevation data was taken also from the SRTM model at 30 meters resolution, in order to create the connection between the accurate geometric connection between these two frames, and to build the digital elevation model. What is important for this analysis is that for this point we obtained on the x-axis, on the horizontal axis, 6.5, 6.6 meters of root mean square error, and 6.0 or 6.3 on the vertical axis. In the literature, it's Professor Galiatatos from the United Kingdom, which obtained about 5.5 for some British sites, which is not so different than our results. But he used econo imagery for pointing the GCP, and we had also evaluated our digital elevation model obtained from these frames. You can see here, but with some profiles from SRTM model. But you can notice these are digital surface models exactly, because it includes also the vegetation. This has to be filtered first of all in order to be more correctly evaluated. But it could be also used. The conclusion is, first of all, we can obtain an accuracy that can be used for qualitative analysis, mainly. Not so much for quantitative at a very detailed scale. Then it's very important to reveal correctly the geometry of panoramic camera in order to make a good orientation of imagery, and also to point correctly and accurate and precisely, if you can, including the point of area triangulation also by fieldwork. It's important to have a network of points. And the shift from image accuracy has a big influence upon the future digital terrain model quality. And this image, with a spatial resolution of about 2 meters, can be used mainly for qualitative analysis. But there could be application of landscape change and urban development, morphodynamics, and landscape evolution. The digital elevation model can be used carefully only after the manual error correction and, of course, after filtration. Thank you very much. Excuse me for not finishing in time.
Thank you, Bogdan. We have time for one short question and one short answer.
Later.
Yeah, later. So, sorry, but we have to move on because we are already late. We are going back now to the presentation which is similar to the first one about flashcards, and which is very interesting.
Hello everyone. I have a much simpler presentation than the two before mine. It is called the assessment of areas prone to flash floods in the Czech mountains. It has the classical structure, the context and aim, and then I will present the study area, the data and the methodology, and finally the results and some conclusions. The context is the study of hydrological hazards in the Czech mountains, which is the topic of my PhD thesis. Normally, because this is a mountainous area, I am specifically interested in analyzing the maximum flows and floods, which leads us to the purpose of this presentation, to identify the areas where flash flooding is most likely to occur and cause great human and material damage. A study area, as I said before, is the Czech mountains. Here you can see that my area is a little bit extended than the normal boundary of the Czech mountain, because I had to include this part with the cities in the lower part of the mountains and these slopes of the Montane Valley. It has a surface of approximately 560 square kilometers and the maximum altitude of 2,500 meters. The minimum altitude here in the southern part is of approximately 517 meters, which means that we have great energy of relief. The data used is, in the first place, digital elevation model. In this case, I used the the digital elevation model given by the project as SRDM90. Then the vector data in shapefile form for geology, soil texture, and land use. And then the mean annual amount of precipitation for weather station within or in the vicinity of the study area. The methodology is the one used by my colleagues Travalier and Costacchi in 2013 in their study case, the catchment Kyoshuri, is an adapted form of the flash flood potential index developed by Smith in 2003, and they called it the flash flood susceptibility index. This is the diagram with the steps I followed to compute the maps, which were summed to give the final result map. First, I used the digital model to generate the catchments, the boundary of the catchments, then to calculate the catchment shape index. From the digital elevation model, I generated the profile curvature, the convergence index, and the slope. Once I had the slope, I could easily computed the length slope factor, and together with the geology land use, mean annual precipitation interpolated with the inverse distance weighting method and the soil texture, I generated the flash flood potential or susceptibility index map. So, with the steps described by my colleagues, I determined five classes for each layer in accordance with their role in the occurrence of accelerated runoff. For example, geology, from pervious, which was notated with 1, to impervious, the slope gradient. The impervious was given the score 5. Then the slope gradient, the profile curvature, and so on. From the catchment shape, from elongated to round, the soil texture, from permeable to impermeable, the land use, from restrictive vegetation for accelerated runoff, that means forest, to favorable or vegetation, that means lack of vegetation on artificial surfaces. And this is the first map. I obtained the main types of rocks, and we can remark the western part with the flysch and metamorphic rocks, and then in the southeastern part the clayey sandstones. Then the slope gradients left and the profile curvature in the right part. The length slope factor and the overflow convergence index. The catchment shape index in the Bucegi Mountains that we can see in the northeastern part, the catchment shape, catchment shape is more round, and that gives us a score of 5 in the FFPI index. Then the mean annual precipitation, the soil types by texture, and the land use. We can see superimposed with the clay sandstones, we have clay soils, and that will have a great impact in the FFPI calculation. This is the synthesis of these classes, and you can see the index has values from 14 to 39, from very low to very high potential of flood occurrence. And the result is this map. where we can see that a simple statistic shows, statistic calculation shows that 13% of the area analyzed has a very high flash flood potential, and we can see three areas of high risk. First, the Bushten city and the northern valleys of the massif. Even if in this area there are no permanent human establishments, these are the valleys with great flux of tourists, mostly during summer. And in too many cases, there are human victims caused by these flash floods. The second area is Sinaia Komarnik, the city Sinaia and Komarnik, where periodically there are some parts of these towns that are flooded. For example, in Sinaia, there is a train station, and the violence of these floods brings not only water, but a lot of alluvia that damages the private properties here in mostly in the upper part of these towns. And the third area is Clot Puchen, or we can say the entire Yalomichara catchment. As I said before, this geologically, lithologically, this is an area with clay sandstones, and the texture of the soils is clay. So we don't have only flash floods here, but landslides also. The conclusion is that this index gives good, accurate, and reliable enough results. The structural measures against inundation and landslides are required, especially in the Yalomichara Valley and in the vicinity of the Mina city. But it is hard to take such measures because they are part of a national park. The strict that part of the strict protection area. So the structural measures can be taken in the area of the towns. And then I think the results of this method could be improved with method data of high resolution regarding soil, geology, precipitation, and terrain model. Thank you.
We have time for questions.
Can you explain the main reason that you use this RPM 90 meters, not 30 meters?
Because when I started this study, I had only the 90 meters digital model, and then I continued to have some continuance in my studies to use the same digital model, so the results would be in the same, the same resolution, the same.
30 meters is available from April this year.
I try to recalculate. It's not my only study, and the other ones from the year before or 2 years before were with the 90 meters.
Just a comment. It's a very interesting case on that domain. Flash floods are some of the main hazards in the Carpathia, especially related to recent deforestation and to climate change, to the increase of torrential rainfall. The flash floods are generated by heavy rainfall, so the mean annual precipitation index is not enough to evaluate accurately this process. So I suggest you to try to find the interface months with heavy rains, with forest recovery.
Yes, thank you. Yeah, I know, and also the mass of air that comes. I mean, it's a mountainous area, and we have convective rains. So I have to take the aspect of the yeah. That will be my next step. Thank you.
Next, we need to move on. The next block is about change detection analysis of the spruce forest in the Romanian Carpathian, and the talk is given by Abraham.
Thank you for introducing me in our work. It is known that the spruce forest, which I chose, forms one of the most sensitive vegetation levels in the Romanian Carpathians. So we have two aims in our study. First was to analyze the changes on the spruce forest extent in the Căpățânii Mountains during the last about 30 years using Landsat imagery. And our second aim was to identify the major general and specific drivers of change in the former and current economic state. This is the study area located in the South Carpathian chain, Căpățânii Mountains. The materials we used were Landsat imagery of three generation, EM Plus, and Olympians from 1986, 2000, 2011, and 2014. We obtained change detection data, vector data sets used, which we used as supplement data, climatic data, and statistical data on livestock and forestry for assessing the drivers of change. This is a simplified methodology workflow. First, we applied the maximum likelihood method to obtain a supervised classification by 13 classes and 15 classes for the cloud cover 2014 image. The second step was to classify the combining classes in order to obtain two major classes, which is spruce forest and non-spruce forest. And finally, the change detection analysis on specific time intervals, which are 1986 to 2000, 2011, and 2014. The initial classification required very accurate as possible separation of classes. That's why we obtained up to 15 such classes, but the ones which we focused on were the first three. We tried, and I think we succeeded in grouping the age classes established by Optima into three classes for analysis, and these classes are 2 to 20 years
which means the first class, first age class, then 20 to 50 years, which means the second to third age class, age classes, and over 50 years, which means fourth, fifth, and sixth classes. The reclassification maps show significant seasonal differences between the three forest classes, and that was one of our issues in our analysis. But inside the spruce forest, we could observe significant change from one class to another. I mean, from very young forests in the natural restoration process into young forest, then of the young forest into mature forest over 50 years. These maps show for each image, for each landscape image, the distribution of spruce forest and non-spruce forest. And on specific areas, we can notice significant change if we consider the red, green, and blue colors, meaning the three age classes for spruce forest. So here, for 1986, we can see that the red color is prevalent, and of course the light green, which is recent clear cutting for that time. Then in 2000, these classes are replaced by ecological succession, meaning vegetation which is in the restoration process. And finally, in 2011, the young spruce forest is becoming prevalent, meaning the dark green. The same process can be noticed for the decoupled benzene. You can see here the prevalence of blue color, meaning ecological succession, and then dark green becomes prevalent, and finally here, especially the red color, meaning mature spruce, is prevalent, which shows a natural restoration process, which is normal in the condition of progressive cutting of the spruce forest in the Carpathians generally. And this is the third example of the forest linguistic Carpathians, which meet the same conditions for recovery here and finally here. The change detection analysis, because what we've seen by now was the assessment based only on supervised classification. The change detection analysis was performed on two specific time intervals, 1986, 2000, and 2011. The assessment for the most recent interval, 2011-2014, was limited by the high percent of cloud cover, over 15%. Anyway, the 25 years are long enough as an interval to allow us to assess the evolution and the natural restoration process of this forest. Overall, the spruce forest, including all the three age classes, encountered moderate losses, but also significant gains by the natural restoration process on the formerly clear-cut areas. The losses were estimated to be about 7%, according to the general statement expressed by collaborators in 2013, meaning that forest cover declined in Romania by 1.3% from 2000 to 2010. But natural restoration was the dominant process inside the spruce forest area. These are 2%, significant percent, meaning that young forest became mature by about 11.2%, and vegetate after ecological succession, the spruce forest gained inside the second age class about 24% of class total in 2011. The satisfactory results on age class separation inside spruce forest were one of the most important achievements of our study. But significant changes in seasonal differences, for example, June versus August, September, limited the change detection analysis. Of course, we accepted this disadvantage because the lack of data from the same month needed for each year, and we try to found a relationship with the natural and the economic and social drivers of change inside this vegetation level. For example, natural drivers of change with the most important factor, which is climate change, show a progressive increase from 1980 to 2007. This warming was also documented for other Carpathian units, for example, Yezen Mountains, by colleagues. Economic and social drivers of change are until 2000 the decrease of logging and shepherding, which finally allowed the natural restoration of the spruce forest. Then, after 2000, the increasing economic interest for shepherding because of the economic revival, subventions like APIA, and the forest restitution and recent clear cutting since 2000 caused some of the most significant losses inside this vegetation area. This diagram showing the increasing of sheep livestock. I'll show you, and this is the final step. I'll show you an example, a negative example of tourism, so-called tourism development, which is the Corpul-Roman tourist complex, which, along with
recent forest restitutions in the area led to significant forest losses. You can see here major interventions in the subalpine and of course subalpine level and of course on the timberline and inside the forest level. This is the location of the future tourist complex, and these are major logging interventions in the area. These are the conclusions which briefly comprise all that I've said until now. I want to insist on them. And then
Do you have any assessment of the result of the classification to see, because they are quite fuzzy.
These results vary from one image to another. First assessment, I think.
The first classification,
yes, of
the
course.
results.
Yes, we have, but we with the presentation. Are quite poor for 1986, below 80%, and very good for 2000 and 2011, over 90%.
So how sure are you about the 7% of loss? That error is not the error of the methodology, for example.
Of course, it is an error. I said that it's about, not what specific. These are the limitations of the method, and I already said that we have necessary data for ideal analysis. Thank you.
Thank you. The next talk is about management outline, and the talk is given by
Good evening. My name is Marina Rușoțumare, and I am a PhD student at the Faculty of Geography, University of Bucharest. I will talk about methodology for mapping land cover using remote sensing data and GIS technique. I'm gonna start with land cover definition. Then I will announce my motivation, the areas of study, the methodology, the results, and summary and future plans. I decided to have a land cover definition because land cover and then land use are used together, and there are some differences. Those definitions are given by inspired directive. Land cover represents the physical and biological cover of the land, like built-up area, forest, wetlands, water bodies, while land use represents territory characterized according to its current and future planned functional dimension or social economic purpose. So land use can be inferred from land cover. What I'm going to obtain is land cover data sets for selected Subcarpathian region. Land cover is an important factor for different geographical analysis and spatial planning application. It is a dynamic variable because it reflects the interaction between social economic activities and regional environment changing. For this reason, it is necessary to update frequently this land cover dataset. There are many land cover models produced at global, continental, or national scales, but they are not every time accurate at regional and local scales. Also, they are not every time updated to the new changes in the landscape. Some of these available land cover are Korean land cover, global land cover, MODIS, and etc. My objective is to produce select cover data sets for selected Carpathian region at regional and local scales by integration remotely sensing data with currently available land cover models as well as GIS and cartographic techniques. The last objective is to generate map layouts at different scales and compare these results. The study area is located in the Carpathian Subcarpathians between Prahova and Television rivers. It is characterized by complex features as an effect of the increasing of anthropogenic pressure by settlements, land uses and mining during the last 200 to 300 years. And it includes a variety of morphostructures like hills superposed on anticlines, depression on synclines, relief inversions, and geomorphic processes. The most important part of my presentation is the methodology. The data sets used in the analysis were satellite images, Landsat 8 poly, Korean land cover model, global land cover 30 model, elevation, orthophotos, and normalized differences indexes. The first step was the image processing, which includes geometric corrections and atmospheric corrections. There was obtained atmospheric corrected data for multispectral bands, and in those pictures you can observe two color combination, true colors and false colors. The second step was to classify the image, and I chose two algorithms, minimum distance and maximum likelihood. The both are based on training areas, and there was obtained two land cover maps. Minimum distance algorithms assign a pixel to a class using the minimal spectral Euclidean distance, while maximum likelihood algorithm assign a pixel to a class using the highest probability. Those classification were compared with NDVI, NDBI, and NDWI, normalized the differences for vegetation, build-up, and water index, and with orthophotos. The next step was to integrate the image classification with the land cover models, because the land cover vector data set from classification have some problems, like build-up area and riverbeds are classified in the same class. They have related spectral signature, and also the free trees and forests. I have to use some ancillary data from land cover models, from Korean land cover and global land cover, and they were integrated in a new data set. The next step was to validate this final land cover data set with orthophotos and high resolution satellite image from QGIS, and with photos. There is an example. This map show the land cover for the study area, and the features are forest, grasslands, free trees, and so on. I map these land cover data sets at different scales. This is for the entire study area, but I have some details and photos to compare, like Padinasa Lake and orchards in below valley, and another with those land cover features, and with the Campina city and Rebel village. The spectral signature of some pixels are related, even they are not from the same land cover classes, and they are not distinguished, like built-up area with the riverbeds or forest with fruit trees. For this reason, it is important to use ancillary data to differentiate those classes. In this analysis, I used vector from the available land cover models. And the input data have medium spatial resolution, so the outputs have a lower accuracy at the very detailed scales. The validation is very important, and I'm planning to make a statistical validation of the results. Also, I'm planning to use a satellite image with high spatial resolution to generate more detailed cover maps and send them to when they will be available. Thank you very much, and excuse my emotions.
Thank you. just one.
Only one comment, because Marina is my PhD student, and she's going to leave Romania for 1 month to go to Spain for Alcalá de Henares on Monday. So I would like to congratulate her because she did an important effort in order to find a solution. Because when you have GIS analysis to develop, it is only one layer that cover or land view, and usually it's very simple to take some data like coordinate cover and others. But we discovered working, for example, for Tlacopa County, there are big errors. Like you have at the top of the mountains, the 1,500 meters arable land there, which is not real because it's a confusion. And of course, all charts on Coordinate land cover, which is also derived from satellite imagery of Landsat, are not very accurate.
I'm sorry, we have to move on to the debate.
So this is the big problem, which is also a team of research, which has to be developed in the future. Thank you.
Thank you. The next talk is a different topic. It's about shapes and characteristics of the display. So I invite the last speaker.
Good evening. My name is Andrea Marin. I'm PhD candidate with the University of Bucharest. My supervisor is Professor Iuliana Armaș. In the next 5 minutes, I'll try to make a summary of methodology used and results obtained in, I can say, preliminary study in our research on shape characteristic of fluvial islands. For starters, I think everyone knows that shape describes the geometric form of individual objects. It holds an important role in many fields such as spatial science, computers, mathematics, or cognitive science. There has long been interest on shape in geography, particularly as it relates to a spatial feature. Although shape has been primarily used as a descriptive element, it has also been of value as an analytical tool. The evaluation of shape is challenging simply due to the fact that there is no universally agreed on how to quantify it. So shape in systems fall into two classes: single parameter, such as areal perimeter calculation, multi-parameter parameter, which involve more complex mathematical functions. The purpose of presentation is to quantitatively characterize shape parameter of fluvial island using GIS techniques. It's important to mention that we focus only to open source GIS solution. Perhaps maybe our people wonder why it's important to know information about the shape of fluvial island. The answer is simple. Fluvial islands have a morphological, an ecological, and economical point of view. Aspects of fluvial islands indicate us how external factors affect them, or can indicate if their surface can serve a particular purpose. For a case study, we choose the Danube sector between Giurgiu and Oltenița cities. Fluvial islands may not be permanent on the geological timescale, but can remain in the place over years and years. So, just to track their evolution from 1864 to 2010, using historical maps like submarine map of southern Romania, Romanian map series anti-number projection system, Romanian topographic map, and orthogonal plan for 2010. The boundaries of the all positive landforms, that means fluvial bars and fluvial islands, from riverbed were digitized, and then for all polygons would have been automatically calculated 7 metrics. Then with an elongation ratio, area, perimeter, interior age ratio, and shape index. How I mentioned, we use only GIS, OpenGIS software, such white box gate, quantum GIS, and Saga GIS. The challenge for us was the challenge to find a way to automatically calculate the length of each island. Why was challenge? Because geometrical they have an irregular shape. So after some searches, we conclude that to each irregular polygon should assign a rectangular polygon which needs to rotate according to the first polygon orientation. Maybe it's easy to understand for the human mind, but for a computer it's a little difficult. Such an operation is known as the minimum bounding box or minimum bounding rectangular. Unfortunately, the list of the open source GIS software that have implemented this tool is very, very limited. So finally, I can say that our salvation came from white box gate open source project. Next, for the automation of the workflow, all processing functions were joined into a single graphical model, which has been run for each year. We choose to create and use a graphical model because it offers some advantages, such as combining a large number of processing functions, using parameters and values stored as variables, and we can share our model with the other user who have performed the same operation. This is the graphical model used in analysis. For data input needs vectorial data set, and then the model calculates count using frequency analysis algorithm and calculate the elongation ratio. Both algorithms are from quantum GIS, and then using algorithm implemented in Saga GIS, they are calculated area, perimeter, interior age ratio, and shape index. Results, we have 4 data sets. And for each year we calculate the metrics mentioned earlier. We can observe that in their study, the fluvial island increased slightly from 19 to 26. And the total area ranging from 21 square kilometers to 27, 28 square kilometers. From 1980 to 2010, total area decreased with 3 or 4 square kilometers. The values obtained for the elongation for interior age and shape index leads to the same conclusion. So I will detail only one of them. Elongation ratio is the ratio of maximum length and maximum width referring to the energy consumption of the river in the neighborhood of the island. Using the classification proposed by Zmeakis and our addressing, we identify four classes. When elongation is less or equal with 2, that means quite round shape. Elongation is between 2 and 4, that means round shape. Elongation is between 4 and 6, that means elongate shape, and this is a mistake. Elongation greater than 6, that means we have a strong line elongate shape. In our case, in 1864, we can see that the fluvial island have a predominant fluvial island with round shape. Then we can see that the fluvial island with round shape and elongate shape increase. In 1918, the trend is the same. We can see that the shapes, the fluvial island have elongate and strongly elongate shapes. The same trend is for 2010. Interior age ratio is the ratio of perimeter and area. And shape index is based on the ratio of perimeter to the square root of area. Conclusions: the shape horrible island turned from a round aspect to a more elongate one. This highlights an intensification of erosion in riverbed of the Danube and a decrease of accumulation factors. In our opinion, we think that the knowledge of the information on the shape of fluvial island is relevant for river restoration strategies, natural conservation of island, and maintenance of the protected habitats. That was all, so thank you for your attention.
One question. So it was the last presentation from the second part of the session. Please bear with us another 10 minutes because the closing ceremony will be here and it will be last week, and we need about 3 minutes in order to arrange the event of the chapter. Thank you.
Please use also the chair that is in the center, please, because there will be a long housing ceremony. It's only for photo to be the impression, but it's more person. Okay, please also.
Laura, știi că ești transmisă live pe YouTube asta? Se vede cât de vesele de camere la geografie.
We can start. You can start to finish. You're invited, dear students, dear Stefan the Great, also because look, we have more direction. You can see it's multi-vision. Okay. Our conference, EcoSmart International Conference, Environment at the Crossroads, Smart Approach for a Sustainable Future, that marks 115 years of geography education at the University of Bucharest and 25 in the 50th anniversary of the Faculty of Geography passes very fast. I hope that you are very content about the level of presentation, about location also, and I think you find that this conference was an opportunity to develop new partnership in research and teaching area. We have a high number. We had a high number of presentation and poster, 195. With very interesting topics. GIS in remote sensing was very interesting presentation. More presentation, hydrology, climate change adaptation, environmental science, urban ecology, sustainable spatial planning, applied geomorphology, urbanization and territorial planning, demography, tourism, novel teaching strategy, geography, environmental science. And I hope that I don't forget nothing. I would like to thank you, all of our special guests. First of all, the new member of our academic community, Professor Emanuel Reinar, now is from University of Bucharest, not from University of Lausanne, and Professor Jürgen Breuster, also from University of Dalby, but now it's from University of Bucharest also. All the plenary speaker, Dagmar Hasse, Chang Hengzi, sorry for pronunciation, Gerald Beltrando, Ibrahim Atalay, Professor Academician Dan Bolteanu, Professor Ioan Janos for the very interesting subjects. And I want to thank you all the colleagues from the foreign university and the research institute that come with us. Please consider that you could find in Romania and also in the University of Bucharest the best fitted partners for your project, not only in teaching but also in scientific research. And I hope that you will visit us again, Romania, not only in academic interest, but for holidays, but we wait also for partnership. I will also like to thank you all participants of the Romanian scientific community, geographers, architects, urban planners, biologists, engineers, and others from the other higher education and research institutions, but also from the private sector. Faculty of Geography acknowledge all of the partners that sustain the EcoSmart organization, Intergraph Computer Services, Multidimension and Domeniile Sămureș for financial and product support, University Association for logistics support, Ministry of National Education for funding, Society for Urban Ecology and International Geographic Union for very interesting workshop, Elsevier Press that help us to publish proceedings in. We hope that in March next year will be online. A proceeding in environmental science, and please consider that the deadline is in December 15, and we expect to publish only the paper which is at the high level. Also, I want to thank you, Econat, for online streaming. Thank you, Harry, because you are here. Bogota is far away, but is for geographers, for partners, the distance is not important. The company that have yesterday the exhibition, S3 Romania, ProSensor, TeamNet, and also Intergraph. Some colleagues that provide us some products, water, wine, and other. Marius Matache, Daniel Diaconu, Mihaela Belga, and other are more. We have more support. Photographic group Circle. I don't know why it's a good translation. Vasile Senku. I think for beautiful photos. Thank you, Julian, for coordination. The photography photographers, and we hope that we have free of charge the photos, and that our educational partner, and I hope that not finally of our friendly West National Military Center that offer the possibility to have this beautiful location. Also, I would like to thank you, the entire Faculty of Geography, for confidence, support, and very active involvement in organization process, but especially of our leader here from Dean, Professor Laura Comunescu. It was important to know that our efforts were sustained at high level, of course. Also to all proteins, but especially I want to thank you, a special thank you for my colleague Ioaraclius for all her efforts, and was very high efforts, I understand. And Professor Cristian Telângă. I want to also thank you all head of departments, all my colleagues that propose more idea and have involved in the organization process. Alexandru Lederea that facilitates access in this wonderful building. Liliana Dimitrache for the very well organized workshop and for all support. Professor Nicolae Taionac for technical support. I address a special acknowledgement to Professor Liliana Zaharia, Daniela Dubrăvean, and Mihai Bogdan for all their support and efforts during this conference. We have more colleagues that participated to the organizational processes, but I would like to remark our team from the regional geography and environment departments. Of course, was our responsibility, but I want especially thank you, Mihai Miță. I transmit my respect for your impressive efforts to be everything perfect. And I think was everything perfect, is everything perfect. I also remark Cristiana Ciocănea for all supporting materials for the conference, bags, porcelain, and other. Diana Onose, Gabriel Pânău, Julian Nicolae, Athanasios Gabrielidis, Simona Gredinar from the Center of Environmental Research, Celtis Group, coordinated by Ileana Stupariu, my colleague Juliana Vijulie, that is in the presidium now, with Gabriela Mana and Laura Taylor, also for coordination of the field trip from tomorrow. It's included here. My colleague Nicolae Mocanu for very well organized of the poster section. Thank you, Nico. Colleague Ionuț Shandric for okay, for online streaming, but also for very good idea, also related to the organization of exhibition, and also for because you manage a very interesting section. Roxana Cuculici for maintaining good contacts with company, colleagues Vasile Popa and Radu Mirimia for all efforts. I hope that I don't forget any person from my department because there will be the problem. At the end, I would like to thank your participants, our teacher also to voluntary students. Thank you, Association for Geographical Students, and I want to transmit my special acknowledgement to environmental sciences students from environmental geography. That don't resolve the exam, but thank you for your support and also for our master integrated environmental assessment. During the conference, the geography and environmental science demonstrate that have more things to do in this very dynamic society, and also we confirm that Romania and Bucharest, the geographer, have capacity to promote and to obtain high-level research. Thank you all. I hope that this conference was a good occasion to confirm your results, to find new ideas, to start or to continue collaboration, of course, also with us. I hope that our efforts to be a good West, perfect West, was successful, and see you soon, maybe as partner in some project. We declare, together with the leader, okay, with the leader, we declare the EcoSmart Conference successful closed. Thank you very much.